So guys, we will going to discuss the design and implementation of TCP server, which can handle multiple clients at the same time. So the implementation of this TCP server is slightly different from the implementation of a TCP server that we discussed, in which the TCP server could handle only one client at a time. In this design, our TCP server can handle multiple clients at the same time. So you can see that the implementation of the TCP server is entirely done in this function, setup TCP server communication. So going to this function, so in the step 1, we are actually initializing the local variables. So we will discuss the use of these local variables as we discuss the rest of the code. Then the second thing that we are doing here is initialize monitor file descriptor set function. Now let us discuss what does this function do. So this function does nothing, but it initializes the array of monitored file descriptor to -1. -1 here represents the absence of a valid file descriptor value. So we have taken a global array here, and the size of the array is 32, and this function only initializing this array. So this array is supposed to store the communication file descriptors of all the connected clients. So since our server is only starting, at the starting phase, it is only initializing this array. So this array will going to store the communication file descriptors of the connected clients to our TCP server. Then the second thing, as we have already discussed, that when the server boots up, the first thing it does is to create a master socket file descriptor. So here also our TCP server is doing no different thing, and we are creating a master socket file descriptor. Now our TCP server has to provide information to the operating system regarding on which IP address and port number our server is listening. So using this structure, struct sock_addr_in, we are filling the necessary information. So we are passing the address family, the server port, which is again a hash defined constant, which is 2000, and we are assigning the IP address as in ADDR any. We have already discussed what is the meaning of this. And then address len is the value that we have to pass as a constant, and this value is just a constant, that is the size of struct sock_addr structure, right? So now all these steps must be familiar to you, because we have already discussed all these steps in the TCP server design that we discussed earlier. So the next thing that we are doing here is to bind the master socket file descriptor. That is, what does the bind do? We have already discussed the bind is a mechanism through which the server machine specifies the criteria of receiving a packet from the kernel or operating system. So bind is a mechanism through which our application tells the operating system to hand over the packet to the application based on certain criteria. So what is the criteria here? The criteria here is already filled in the second argument to the bind system call. The server ADDR variable stores the IP address and the port number. So any TCP packet that arrives on the server with destination IP address is equal to the IP address of any local interface of the server, and TCP port number is equal to server port number, the operating system would know that this application is interested in receiving these kind of packets. So bind system call does that, right? So we have done the binding of our application successfully. Then in step 4, like previously, we are making a call to listen system call. Right. Now after this, at line number 137, our server has already created a master socket file descriptor. Now master socket file descriptor is also supposed to be monitored by the select system call. So that is the reason that we are adding master socket file descriptor to the array. So we have already discussed that we have taken a global array and we are just adding this TCP file descriptor to that array. Right? On the right hand side, you can see that the TCP server, after creating a master socket file descriptor, has added the master socket file descriptor to the readFDS set. Now this we will going to do. Now we will going to do this shortly. Now as soon as the TCP server has added the master socket file descriptor to the array, we entered inside the server loop. Right? Now we are initializing the readFDS set. Now at this point of time, the server has only one file descriptor to be monitored, which is master socket file descriptor. So in this function, that is reinitFDS, we are emptying or we are zeroing the readFDS set, and then we iterate over our array and we set all the file descriptors that are currently stored in our array to empty underscore set to readFDS set. So the logic is fairly simple. Whatever be the readFDS set, fd underscore 0 macro drain out the entire readFDS set, and then we iterate over our array which stores the master socket file descriptor as of now, and we copy the master socket file descriptor from the array to the readFDS set. So this is what we are doing in this function reinit readFDS. So after this function call, our readFDS data structure would contain only master socket file descriptor as of now. Now the next thing the server is doing is to make a call to select system call. Now what is the first argument that we are passing here to the select system call? Here the get max empty is a function call which actually find the maximum numerical value of all the monitored among all the monitored file descriptors in our array. So we are simply looping our monitored file descriptor set array, and we are finding the max value from the array. And to that max value, we are adding 1. So select system call requirement is that the first argument to the select system call must be the maximum value of maximum value among all the file descriptors that are present in readFDS set plus 1. So such is the synopsis of select system call. So in the right hand side, you can see that the TCP server has created a master socket file descriptor and added that master socket file descriptor to the readFDS set. And then our TCP server has made a call to select system call, and by making a call to select system call, that our TCP server has been blocked. That is, it is now waiting for new connection request from the client. So this call will unblock when the new connection request would arrive from any client. So in the following code, we have to check the reason why the TCP server has been unblocked from the select system call. It could be because of two reasons: whether the TCP server has received a new connection request from the new client, or already connected client has sent a data to our TCP server. So the first condition can be checked by using if underscore fd underscore is set macro, and we will check whether our master socket file descriptor has been set or not, or has been activated or not. So we does that by using fd underscore is set macro. Now suppose this condition is true, it means our TCP server has received a new connection request. So the second thing our TCP server will do is to accept the connection, and the return value of the accept system call will be the communication file descriptor. Now using this communication file descriptor, our TCP server will carry out rest of the data exchange with the client that has just connected to us. So this communication file descriptor will be added to our array. Remember, our array is nothing but it is a collection of communication file descriptor of the connected clients. So you can see in the diagram on the right hand side that as soon as the client has sent the connect request to our TCP server has made a call to the accept system call, and accept system call has given us the communication file descriptor. This communication file descriptor will be used by our TCP server to carry out all the data exchange with the client. So that is the reason that we have to store this communication file descriptor in our array. So we save this communication file descriptor to our array. So here we have saved this communication file descriptor to our array. Right? Now let us suppose that this condition was false. That means the TCP server has received a data from already connected client. So here we will begin a loop and we will check each file descriptor that we have stored in our array and check whether it has been set or not. Because at the same time, 2 or more clients can also send data. So we will have to check all the monitored file descriptors that are present in our array. Right? So this condition will be true only for those clients whose communication file descriptors have been activated. It means only for those clients which have actually sent data to the server. Right? So remember, read FDS is nothing but it is a clone of monitored FD underscore set array. Because at the time of initializing the read FDS set above, that is in this call, we had copied the entire array to our read FDS set. So you can say that read FDS is nothing but it is a clone or copy of monitored FD underscore set array. Whatever file descriptors are present in this array are also present in our read FDS set. So this condition is true only for clients which have actually sent data to our TCP server. So we will get that communication file descriptor. Now our TCP server has obtained the communication file descriptor for the client which has sent us the data. So the next thing that our TCP server has to do is to receive the data or to read the data which was sent by the client. So again, memset means prepare the memory to read the data received from client and then call the receive from system call over the communication file descriptor. So remember, all the data exchange happens over communication file descriptor, and pass the pointer to the empty buffer so that the data received from the client will be copied to this buffer, size of the buffer, and then pass the empty structure of the type client of the type struct socketDR so that this value or this memory gets filled by the operating system with the client information. Right? So at this point of time, our TCP server has actually received the data from the client. So here we have a condition check that if the client has sent 0 bytes, then do nothing. Just close the communication file descriptor. It means our server is closing the connection with the client. Whenever a server closing the connection with the client, we have to remove this communication file descriptor from the array, which contains all the communication file descriptors of the clients which are being monitored. Right? Now let us suppose this condition is false. So the next thing our TCP server has to do is to read the client data. So remember, we assume that the client is sending the data by formatting as per the test underscore struct underscore t data structure, and this data structure contains two unsigned int variable, which is a and b. So again, we have put the condition that if the client sends the value of a and b as 0, then our server will going to assume that condition as the connection termination condition. So if this condition is true, then our server is going to close the communication file descriptor and remove this communication file descriptor from the array and break. So let us assume that this condition is also false, that is, our client has sent us some values of a and b. So our server has already read those values, and as you know, the functionality of our server is to add these two values and send back the result to the client. So in this line, our server is calculating the result. And then once the result is prepared, using send to system call, our server is sending the reply back to the client. And remember, on receive from system call and send to system call, the file descriptor is passed as communication file descriptor. So this TCP server is actually able to maintain or service the multiple clients at the same time because of this loop. Every time the TCP server detects that some client has sent data to it, our TCP server iterate over the entire array which stores the communication file descriptors of all the connected clients and check one by one that which communication file descriptor has been activated. And for all those communication file descriptors which has been activated, this condition would be true, and our TCP server happily service that client. Another thing to note here is that as soon as the TCP server receives the new client connection request, that is here, that is when this condition becomes true, our TCP server accepts the client connection and add the communication file descriptor that is returned by the accept system call to our array. So basically, our TCP server is keeping a track of all the connected clients. And using select system call, our TCP server is monitoring all the connected clients at the same time. This process is called multiplexing. So here is the select system call. And remember, when we get back into the while loop again, that is the second iteration, we again copy the entire array which we have been maintaining into the readFDS set. This is what this function does, right? So this is the entire logic of implementing the TCP server which can handle multiple clients. And remember, our TCP server is handling multiple clients using only select system call, right? So on the right hand side, if the second client sends the connect request to our TCP server accept the system call, that is here, and get the communication file descriptor and add this communication file descriptor to the readFDS set. That is, we have saved the new communication file descriptor to the readFDS set, so that next time, that is in the next iteration of the while loop, this communication file descriptor will be monitored by the select system call, right? And we have already discussed that whenever there is an instance when the TCP server closes the connection with the client, we happily remove the communication file descriptor from our array so that we do not monitor that particular communication file descriptor anymore. So you are requested to implement the same steps and try out connected multiple clients to your TCP server. I will show you the demo for this. So this is our TCP server. Let me create some duplicate windows. Now in the first window, I will compile the TCP server. So our TCP server, which can handle multiple clients, is implemented in the file mx_tcp_server.c. So gcc -g -c. So we have compiled it. Now I am running our TCP server. So you can see that our TCP server is now straight away blocked on the select system call after creating a master socket file descriptor. Now let me start the client. So since our TCP server is the client, since our TCP server has the capability to maintain multiple connections and service multiple clients at the same time, we will going to connect 3 different clients to our TCP server. So the client is in here. So I'm starting the client 1, and you can see that as soon as you start the client, our TCP server completes the handshake with this client and again blocked on the select system call. Now our TCP server is blocked on the select system call, and this select system call at this point of time is maintaining 2 file descriptors, that is monitoring 2 file descriptors, the communication file descriptor of the client which is just connected and the master socket file descriptor. Now we are starting the second client. So now I am starting the second client. So as soon as I have started the second client, you can see that our TCP server has accepted the connection from the second client. Now I am starting the third client. You can run the same client executable file multiple times in different windows. It is equivalent to multiple clients. So all the 3 clients are now connected. Now your TCP server can receive the data request from any client in any order. And see, we have received the result. Similarly, second client can also send data and can receive a result. The third client also can send the data and can receive a result. Again, back to the second client, for instance, it can send the data and receive a result. So you can see your TCP server is actually able to service multiple clients at the same time. So this is what we had to discuss about TCP server implementation, which could handle multiple clients at the same time. Such a TCP server is called a TCP server with multiplexing.